So as we always do, we want to go through some of the questions. When we are done, then you take the quiz, okay? All right, so our first practice problem. The table sets out the production possibilities of a small Pacific island economy. We have to draw the economy's PPF. Okay, so as we saw, the PPF is just a graph connecting all the production possibilities. So what you have to do is that just draw your axis, one for fish, one for berries. Then you just take any possibility. So when we start from A, the first one is that when they use all their resources to produce 5 pounds of fish, they don't produce any berry at all. So that is point F. And then for point A, when they use all their resources to produce berries, they produce 20 pounds without producing any pound of fish. Then in between the two polar cases, we have the different possibilities or combinations as well. So you just do it for each combination and then you draw the curve through it. As I stated last week, it's not supposed to be a straight line. Okay, it's not supposed to be a straight line. Okay, just to show the trade-off. Okay, as you move down the PPF, there's supposed to be an increasing opportunity cost, an increasing exchange or trade-off that you have to make. So that's the first one, how to draw the PPF. Okay. Then now we've been given a PPF for a particular economy. Now the question is that which of these points from point A to G, which of these points are attainable? Remember we said the PPF gives us some properties. It shows us attainable and then unattainable possibilities. And then it also talks about production efficiency. It gives us possibilities that are efficient and those that are inefficient. And then it also talks about trade-offs and then free lunches. Okay. So for this particular one, looking at the points, which points do you think are attainable?
Attainable at every point except F and G.
Except what?
F and G.
Very good. So the attainable combinations or possibilities are the possibilities within the PPF or on the PPF. Okay, so A, B, C, D, and E are all attainable, but F and G are outside the PPF, so we cannot attain those possibilities. All right, so of course that is the solution. A, B, C, D, and E are attainable, and then F and G are unattainable. All right, so we can produce all combinations. So we can produce all combinations means that we are talking about the attainable ones, the ones that we can actually produce. Those are the possibilities inside the PPF and on the PPF. So that should be option D. We can produce the combinations that are inside the PPF or on the PPF. Okay, so the inside ones are the D and E, and then the ones on are the A, B, and C. Okay, all right. We are using the same figure again, the same PPF. At which points are efficient, and then which points are inefficient? Which points are efficient? Which ones are inefficient? Yeah, Frank.
Efficient are points on the PPF.
Okay.
A, and inefficient is points within the PPF, DE.
All right. Now, if we look at point F and G, they would have been preferred to even point A, B, or C, but then they are unattainable. So, talking about efficiency, the production can only be efficient or inefficient if we can actually attain that possibility. But F and G are unattainable, so we don't even consider them when we are talking about efficiency. So we can only have efficient and inefficient ones when they are either inside the PPF or on the PPF. So the efficient ones, as we said, are the ones on it, A, B, and C, and then the inefficient ones are the ones within, that's the D and then E. Okay, very good. We are using the same thing again. Okay, this is just explaining efficiency and then inefficiency. So now, remember when we're going through the notes, we defined what production efficiency is. When you are producing two goods, okay, and then when you try to increase the production of one, and you lose production of the other good, it means the initial point was efficient. So it is not possible. When production is efficient, it means it's not possible to increase the production of one without producing less of the other. Okay, so looking at this multiple choice, it's saying that production efficiency occurs when it is not possible to produce more of one good or service without producing less of something else. So the answer is A. We'll have production efficiency when there's supposed to be a trade-off. You have to sacrifice something before you get more of the other. Okay, so that is A. Okay, that's A. All right. Now, which points are inefficient? I think we've seen this already. The D and E. Okay, points D and E are inefficient. D and then E. Are we together?
Yes, we are.
Now, we are using the same figure. Which points illustrate a trade-off? A trade-off.
A trade-off points A, B, and C.
Okay, so if you try, we'll have a trade-off whenever we try to move from a point on the PPF to another point on the PPF. Okay, so if you stand at A and you want to move to B, you have to sacrifice more of cars. Okay, if you move again from B to C, you still have to sacrifice more of cars. Okay, so whenever you move from one point on the PPF to another point on the PPF, that is where we get a trade-off. Okay, that's what the trade-off. So yes, the A, B, and then C. When you move from A, B, or C to any other point on it, so moving from either A to B, B to C, C to B, or C to A, that should give us a trade-off. Okay. All right. So multiple choice. A trade-off occurs when we. Yes. Can you answer this one?
When we move from a point on a PPF to another point on the PPF.
So that is option C.
C.
Option C. All right. What about free lunches? We said for free lunch, you're able to get more of one without producing less of the other. So which points will give us free lunches?
D and E only.
Yes, D and E only. So that is option C. When we move from D to less than an E, if we move from E to B, you see that we are getting more of cars, but then we are not sacrificing any of the other good. Okay, so point D and E are the points that will give us free lunches. Okay. All right. This is the production possibilities for a particular firm. Okay. Now we want to calculate the opportunity cost of increasing the production. We are producing berries and then fish. Okay. So each figure that you see here is in terms of pounds. So these are the production possibilities, and these are the combinations. So what if we want to increase the production of berries from 21 to 26 pounds? Okay. Now, what is going to be the opportunity cost? We are moving from 21 pounds of berries to 26. Remember, we said opportunity cost of producing a particular good is going to be the decrease in the production of the other good divided by the increase in the production of the good in question. So here is berries we are talking about. So if you want to find the opportunity cost of moving from 21 pounds to 26 pounds of berries, then we are talking about the decrease in the pounds of fish produced divided by the increase in the pounds of berries that we increase that we produce. Okay, so how do we do this? It means we are moving from point F to point E, right? point F to point E. So what is going to be the change in pounds of fish? That will be 13 minus 15, right? So we'll have 2 there. Minus 2. Of course, it will be minus, but then we just ignore it. Change is new minus old. So the decrease in the pounds of fish will be 2. Okay, 2 pounds. And then the increase in the pounds of berries, 21 to 26 will be 5, right? That will be 5. So the opportunity cost is going to be 2 pounds of fish divided by what? 5 pounds of berries. So the opportunity cost of increasing it from 21 to 26 is going to be 2 over 5 pounds of what? Fish that we have to sacrifice. Is that okay?
Yes.
Right. And then the follow-up question is that, does the opportunity cost of berries increase as it produces more of berries? Okay, we just want to know if there's increasing opportunity cost. So before you can do this, now we know the opportunity cost of moving from F to E, that's increasing the production of berries from 21 to 26 pounds. So if you want to know if the opportunity cost will keep on increasing, let's move again. Let's move from E to D. That is, let's increase the production from 26 to 30. Okay. Now, when we increase it from 26 to 30, the production of fish will decrease from 13 to 10.5. So the decrease there is going to be what? 2.5. Okay, 2.5 pounds of fish. And then the increase in pounds of berries will be what? 4. 26 to 30 is 4. So the new opportunity cost is going to be what? 2.5 divided by what? 4. 2.5 divided by 4. 2.5 divided by 4 is bigger than 2 over 5. Are we together? Let's look at the solution. So the first one that we did, we had 2 over 5, right? 2 over 5. So the opportunity cost of moving from 26 to 21 was 2 over 5. And then for the follow-up, now when we move from E to D, the production of fish will decrease by 2.5 pounds. Okay. And then the production of berries will increase by 4 pounds. So the opportunity cost will be 2.5 divided by 4, which is 5 over 8. This is bigger than 2 over 5. Okay, this is, we can change it to this mindset. So what this means is that as he tries to increase, continuously increase the quantity of berries, the opportunity cost will also keep on increasing. If you remember, during the lesson, we said we have increasing opportunity cost. Okay? Increasing opportunity cost. So that is what happens when he tries to produce more berries. The opportunity cost will continue to increase. All right. Let's look at another question using the same information. Now, assuming he produces 10 pounds of fish and 21 pounds of berries, what is his opportunity cost of an extra pound of berry? Okay. We are assuming that he's producing 10 pounds of fish and 21 pounds of berries. Now, if you check the table, we don't have this combination there. Okay, we don't have 10 pounds of fish and then 21 pounds of berries. When he produces 21 pounds of berries, he was producing 15 pounds of fish. We don't have that combination. So the best way to approach a question like this is to draw the PPF. When you draw the PPF, then you indicate this particular combination. That is where you will know whether there will be an opportunity cost or not. What we have to understand is that when you are moving along the PPF, that is where we do trade-off. The trade-off is the opportunity cost, okay? But then when we have a free lunch, there's no opportunity cost. You don't lose anything. We have opportunity cost when we lose something. But I'm sure we remember for free lunches, we don't lose anything. We're able to increase the production of one without losing the production of the other. So we have to know where this particular point falls. Okay, whether it will be in the PPF or on the PPF. So let's draw there. You see, this is the PPF, okay, and the combination 10-21 is inside the PPF. Are we together? It's
Yes.
inside the PPF. So if we are to find the opportunity cost of producing an extra pound of berry, there will be no opportunity cost. We can even move from Z to D without reducing the quantity of fish. If we move from Z to D, we'll be producing like 30 pounds of berries without losing any pound of fish. So there's no opportunity cost there. Are we together?
Yes.
And then assuming we want to find opportunity cost of producing an extra unit of fish. Now, we can even move from Z to F. We'll produce 15 pounds of fish. See, we've increased it by 5. Yet, there's no change in the pounds of berries. It's still 21. So we don't lose anything. There is no sacrifice. So whenever the production is starting at a point within the PPF, there's no opportunity cost at all. Okay, there's no opportunity cost. So whenever we are producing inside the PPF, we don't experience opportunity cost, but we don't sacrifice any unit of the other good. Okay, so the opportunity cost will be 0 for both. Whether you go here or you go there, the opportunity cost will be 0. I hope that's fine.
Yes.
Now, this table 2 shows an economy that produces education, services, and consumption goods. Okay, so these are the possibilities. This is education services, and then this is consumption goods. So let's look at the question. If the economy currently produces 500 graduates, so 500 graduates, and then 2,000 units of consumption goods. So we are at point C, 500 education services, and then 2,000 consumption goods. Now, what will be the opportunity cost of one additional graduate? Okay, so now we want to increase the production of educational services by 1. Okay. Now, what you have to do is that just move up on the possibility. Okay. Then you see that when we are trying to find the opportunity cost, the reason why we divide it by the good that is being increased is that we want to find the opportunity cost of producing just one additional unit. That's why we divide it. If we were to just assuming moving from C to B, we'll only increase the educational service by 1. If it's just by 1, then there's no need dividing it by 1 again, because any number divided by 1 is still the number. But then if the difference, okay, where you want to move to, if the difference is not 1, then for you to get the opportunity cost of producing just 1, you have to what? Divide it by the change in the good that you are trying to increase as well. So here, moving from 500 to 750 is not just 1. But then we can use this, the change here and the change there. We divide, then we're able to get it for just an additional. So it's educational services that we want to increase. So let's move from C to B and find the opportunity cost. Now, if you move from C to B, the increase will be what? 750 minus 500, right? Which is 2.
Yes.
So educational services will increase by 250. And then consumption goods will decrease by 1,000, from 2,000 to 1,000. A decrease of what? 1,000. Is that okay? A decrease of 1,000.
Yes.
So remember, the opportunity cost will be the decrease divided by the increase. So that will be 1,000 divided by 250. Okay, 1,000 divided by what? 250. So 1,000 divided by 250 will be 4. So what this means is that if you want to increase the educational services by 1, you have to sacrifice 2 units of what? Consumption goods. Are we together? So the opportunity cost of one additional graduate to be 4 units of consumption goods. 1,000 consumption goods divided by what? 250. That will give us 4. So if you need an extra graduate, sacrifice your consumption by 4, consumption goods by 4 units. Okay. So this is what actually causes economic growth. You see that educational service is a capital good. Okay, you are increasing. Remember, we said we have economic growth when maybe there's an increase in the level of technology, an increase in the quality of labor. So whilst people are undergoing education and training, you see that we are getting more quality labor. So this is what is going to help increase economic growth or cause economic growth. But that to mean that we have to postpone current consumption. Now, if you need just an additional graduate, you have to sacrifice 4 units of consumption. The consumption goods are the goods we consume now, okay, for our individual satisfaction. So for you to get more capital goods, you have to produce less of the consumption goods. So 4 units of consumption goods to just one graduate, okay, to just one graduate. Okay, this is a practice problem. So I would like you to try first. How does an economy grow? And explain why economic growth is not free. So let's look at the first part. How does an economy grow? How do we experience economic growth?
Economic growth.
Yeah.
The economic growth when there's an increase in when the what's the name? The PPF increases.
Okay.
And this
when it expands, so
when it expands, yeah, yes, when it expands or shifts outwards, and this happens when there is in terms of technology and improvement in technology, with improvement in the labor force.
Okay.
Yeah. That's what I know.
All right. So I mean, when we have increase in capital goods, increase in the resources that we have, so we experience economic growth when there's expansion in production possibilities. Okay. But then, do you think there's a cost to economic growth? Is economic growth free? Can we just
No,
go like that without sacrificing anything?
no.
So why is economic growth not free?
Because using the PPF, if you're able to produce at the efficiency, meaning that based on the level of technology and that of the available resources, you are producing at efficiency. But for the economy to grow,
Right. So
for the
it's just like the question, just the previous one. You see, I was comparing capital goods to consumption goods. Now, before we can actually increase our or expand the production possibilities, we need more capital goods than consumption goods. Okay, when you produce consumption goods, they are directly consumed. They are not used to further produce any goods. But then when we produce more capital goods, those are the goods that we are going to use to further produce. That expands our production possibilities. But then the more you produce capital goods, remember we have limited resources. So if you want to produce more capital goods, you need to sacrifice some of the consumption goods that you produce. So the cost of economic growth will be the consumption goods we have to sacrifice. That's why they are saying economic growth is not free. If you want to grow tomorrow, today you have to suffer. You have to postpone current consumption, current enjoyment, even as an individual. If you want to get more money tomorrow, you don't have to consume more today. You see, you have to save your money, invest your money, so that tomorrow you can get more. But whatever you get today, if you consume it now, you enjoy everything. And tomorrow, you wouldn't have anything to enjoy. Okay, so yes. How we grow, we can only grow when we expand our production possibilities. So just as we said, we do this when we develop better technology. So these advanced countries, you see now they have better technologies. They've improved their quality of labor through education, training, work experience. And then they produce more machines, more capital goods. Okay, those are the resources that actually aid in producing more. So yes, this is how the economy grows. But then the resources we are using to better our technology, to better the quality of labor, to produce more machines, those are the same resources that we use to produce goods and services. So if we are now using them to produce these capital goods, then we cannot produce the goods and services. So we have to sacrifice the current production and consumption of those consumption goods. Then we produce the capital goods. So we have to sacrifice those ones. That's why we are saying economic growth isn't free. The cost of economic growth is the consumption goods that we have to sacrifice now. So we don't have to enjoy so much now so that we can enjoy tomorrow. Okay, so that's the cost of economic growth. Are we together?
Yes.
Okay, let's look at this. Trade, okay, trade and specialization. So these are two people producing two kind of goods or services. I don't even know what this is. What is this? I don't know.
I have no idea. I have no idea.
Okay. Right, so these are the two goods that these people are producing. These are their production possibilities, okay? These are the production possibilities that they have. All right. Now, who has a comparative advantage in producing snowballs? And then who has a comparative advantage in producing, I don't know if it's skies or what. So we'll have to actually calculate their opportunity cost. Remember, we said you have a comparative advantage in production when you have the lower opportunity cost, if you produce it at a lower opportunity cost. So let's look at, please, let's follow. Let's look at
Okay.
the first one. Now, assuming we want to find the comparative, who has comparative advantage in producing snowballs. So from here, assuming this guy wants to increase his production of, okay, let's use this one for the snowballs, okay? So initially he wasn't producing any snowball at all. Now he wants to produce 5, okay? So now if he wants to produce 5, then definitely he has to sacrifice some units of skies, right?
Yes.
Good. So moving from 0 to 5, we have to move from 50 to 40 for the sky. So what is going to be the opportunity cost of producing a snowball? Let me write it here. That will be the decrease in skies, right? That is going to be 10. Is that okay? That's
Yes.
10 divided by the decrease, the increase in snowballs. That's going to be what? 5. So we'll have an opportunity cost of what? 2. That is for snowball. Now let's go to party. For party, if he wants to increase production of snowballs, here we want to calculate the opportunity cost of producing snowballs. So here his increase will be 10, right? The decrease will be 10 to 5 will be 5. So decrease divided by increase. Increase is 10. The snowballs will increase by 10 units, and then skies will decrease by 5. So here the opportunity cost will be what? Half. Is that okay? It's going to be half. So what this means is that party will have a comparative advantage in producing snowballs because he has the lower opportunity cost. Is that okay?
Okay.
That's it. So the first one for snowballs, we are going for party. So the comparative advantages for snowballs for party. Now let's look at skies. Now for Tony, if he wants to increase the production of skies, he'll move from 0 to 10, right? 0 to 10. Are we together?
Yes, yes, yes.
0 to 10. So the increase will be 10 here. And then the decrease, 25 to 20. That will be what? 5. So here, the opportunity cost of producing an extra unit of sky will be what? 1 over 2. Okay? 1 over 2.
Okay.
Then we come to party. To increase production of skies, snowballs will decrease by 10. So 10 divided by 5, right? 5. So this is going to give us 2. So what do we see here? Here, for the production of skies, Tony rather has the lower opportunity cost. So he will have the comparative advantage. Okay. So that's what we have now. Party has a comparative advantage in producing snowballs. And then Tony too has a comparative advantage in producing what? Skies. Are we together?
Yes.
All right. Okay, so this is what we did. Okay, let's look at the next one. Now, assuming Tony produces 5 snowballs. 5. Tony is producing 5. So here, this way he is on this possibility. 5 snowballs and 40 skies, right? And then Patty is producing 10 snowballs and then 5 skies. This is their initial possibilities, their initial what they were initially producing. Now, if they all right, I hope you can hear me.
Yes, I can.
Okay, right. So this guy is producing 5 of snowballs and then 40 of skies, and then this guy is producing 10 and then 5 of snowballs and skies respectively. So if they specialize and then trade, what will be the gains from the trade? Okay, now specializing means that they will all go for the good or service that they have a comparative advantage, and we saw that party has a comparative advantage in producing what snowballs, right, and
Yes.
then Tony in the production of skies. So if they are specializing, it means that Tony is going to produce 50 units. He will only produce skies. Okay, and then
Okay.
party will only produce what snowballs. That will be what 20. Okay, just to avoid the right things, let's look at the solution. All right, so as I was saying, when they specialize, okay, party will produce only snowballs, so that will be 20, right? And then Tony will produce only skies, that will be 50. But then initially, let's look at the total units for the two goods that they were producing. Now, initially, Tony was producing 5 snowballs, and then Patty was producing 10, which means that in total, they were producing 15 units of snowballs, right?
Yes, yes.
And then for skies too, Tony was producing 40 skies. Patty was producing 5. So in all, they were producing what? 45. Is that okay? 45.
Yes.
But then if they specialize, now the total number of skies that will be produced will be what? 50. You see that
Okay.
it's more than what they were.
Yes, they were doing it with them. Yeah.
And then now, when party 2 produces only snowballs, he is producing 20. And that is more than the 15 that they were both what producing. So can we see again here? They are
Yes.
there's an increase in the production of both goods by 5 units. Okay, we've moved
Yeah.
from 45 to 50, and then from 15 to what? To 20. So yes, there's a gain there. So what do? They can come together. Okay, when they come together, then they just trade one snowball for one sky. One snowball for, because I have increased my production. See, initially this is where they were, right? 10 and then 5 and then 5 and 40, right? Now
Yes.
we've produced 50 of skies, and then we've produced 20. Okay, so now this guy will give this guy additional 5 of what snowballs, so he will have 15, and then this guy will have what 10. Are we together?
Okay.
Then when we come to skies too, this guy will give this one 5, so now you have what 10, and then he will have what 45. So you see that they've all gained. Initially, you were producing just 5. Now you are producing 10. You were producing just 40. Now you are producing what 45. That's a gain for you. This guy too, initially he was producing only 10. Now he's producing 15. He was producing only 5 here. Now he's producing what 10. So you see the gain. So when they specialize and they trade, they gain. They gain from the specialization. Okay. So that is a very nice question on specialization and then trading. Okay, so they all gain. They trade one sky for one snowball. So you give me 5 of yours, I also give you what 5 of mine. All right. So they all gain. At least we've collectively we've increased the production by 5 units each. Okay, by 5 units each. All right, so this is where we will end. I will send you the link, so in your free time you can go through it. Next time, tomorrow we'll start with the market forces, demand and supply. Okay, so
Tomorrow, I thought it's Thursday.
I said Thursday. Okay. All right.
Yeah.
We'll make it Thursday. But then I will send you the link. So we'll try.
Okay.
Okay. Have a wonderful.
Okay. You too. Bye.